This is our project for the Global Classroom. It's called Feeding Growing Urban Populations, a historical analysis and consideration for future scenarios. I'm Erin Barton, and with me is Hendrik Stepke. And also helping us with this project are Lyle Johnson, James McDonald, and Luca Brennick. The professors who support us were Professor Dr. Montford Lavigler, Professor Dr. Sander van der Loo, and Leonie Bellina. So to start off, we're just going to give you a few numbers to keep in mind. There are 7.3 billion people in this world, and it's estimated that 54% of those people currently live in cities. That's more than 3.7 billion people in urban centers. And by 2050, it is estimated that over 90% of the world's population will live in cities. One thing is certain about the future of those populations. It's something we all need today and we'll all need in the future. We all need to survive. We all need food to survive. We all have seen ominous news headlines warning us of our demise if we don't fix our food production system. If you fall into the news headline trap, a system collapse seems imminent. These issues fueled our team, so much so that we dedicated our entire project to it. Why, we wondered, despite advances in agricultural technology, research, and policy, do people suffer from food insecurity? With this general question, we set out to work to develop our project. We decided to look at the connection between urban centers and agricultural lands and the relationship between these systems, specifically how they connected in the past, the present, and the future. The assumption that a growing urban population requires a growing food production system is one we've found that we need to move away from. Instead, we need to take into account historical path dependencies which restrict change and have led to a food system with increasingly unsustainable and unintended consequences. We need to understand how we came to this point in order to make the best systemic change going forward.
To structure the team process and find a way to approach our questions, we developed a research design that is inspired by and based on complex adaptive system theory. This theoretical framework gave us not only a way to break up the research process into different phases, but also gave us the core concepts to carry out our analysis. The basic structure of the project was to have a historical analysis of three major agricultural regimes: the colonial, the industrial, and the development regime, which all happens in phase one. Then we wanted to do an in-depth analysis of the present neoliberal regime, considering the path dependencies from phase two. And then we wanted to project these path dependencies into the future as scenarios in phase three. The basic idea of our complex adaptive systems approach was that regimes go through major shifts after reaching crucial tipping points, and that we could gain an approximate understanding of the system's path dependencies by condensing a literature review of the regimes into networks that would graphically display the main features of our historical periods.
There were several key findings that came out of our research, which we found by creating a visual set of networks, an example of which can be seen on the slide. One main point was that our current agricultural system has been created and is limited by historical path dependencies that control the choices we can make in the present. Another key finding was that the growth of megacities is intrinsically linked to the agricultural system and the direction that it takes in the future. The creation of megacities may not be an inevitability as many people seem to think. Finally, we found that in order for us to alter our current agricultural system, it would require another regime shift that breaks the path dependencies built up since the 16th century colonial regime and creates a positive feedback loop towards a new, more sustainable regime.
As we extended our findings into a set of future scenarios, we found that path dependencies that put agricultural oligopolies in power in Mexico and the US are strong enough in the current economic system that they will not likely be overcome by current agricultural movements in a business-as-usual scenario. This means that in the big agricultural scenario, transnational agricultural oligopolies will continue to dominate the global food system and dictate how growing urban populations will be fed. Moving forward, these path dependencies will lead to continued urban growth as even more of the rural populations will be displaced to the cities in order to find work and access to food that they are no longer able to produce themselves. All these developments contribute to making the feeding of growing urban populations more of a challenge as we approach our global carrying capacity, particularly in the absence of a dynamic system change that moves the world away from business as usual big agricultural scenario. Therefore, in the context of the global classroom, sustainable cities, a contradiction in terms, we are left to wonder. With the challenges we are facing relevant to feeding growing urban populations today, currently with just 54 of the world's population in cities, how will we manage with over 90% of the world's ever-expanding population residing in urban environments by 2050? Sustainable cities, in this context, may very well be considered a contradiction in terms.